Hello everyone, am I audible?
Yes, sir.
Okay, thank you so much. So, I'm Dr. Hijaz came here from Spark Institute of Advanced Science. So, today we are starting our course on Mathematica, Start to Mathematica. So basically, as you have all seen, Dr. Dilip will be joining us and he's already in the meeting. So before that, I'll just give an introduction about our organization and the kind of programs that we generally organize. So maybe some of you are already familiar with it because some of you have participated in our earlier programs and many of you are not familiar with us. So just let me introduce about our organization. So I will share a PPT and we'll talk on that. So I hope you can see my screen, see the PPT, right? So
Yes, sir.
yeah, so basically this is what we do. We give academic coaching programs. So earlier we did coaching programs for Central University PG entrance exams, IIT's JAM exams, etc. So that was one vertical that we do, and another one thing is one more important thing is the research forum, CIAS Research Forum. So under the umbrella of CIAS Research Forum, we are organizing the programs like what you are right now in, like Mathematica and many other things. So so in the research forum, people can also take membership, and it is also an opportunity to network each other. And we conduct workshops, trainings, and we collaborate with different academic institutions and industry partners. We also do some research consultancy works, and we are also planning to be in publications as well. We are already in publication, and we are going to um, give more time in the publication arena in the near future. So these are some of the coaching programs that we did previously. And so one interesting thing is that you can take a membership of our forum, and the membership will give you an opportunity to network around among your peers, and also it will give you some financial benefits on depend when you're joining in our future programs. So that is also there. So you will be getting more details of all these things in the emails, which we will be communicating you day by day as the course moves on. And at the end of the course, we'll be also sending you the certificate. So at the time, there will be a more detailed explanation on how you can be a member and what are the benefits, etc. Okay. So we also help students to do help students in grading projects and internship. So those students, undergraduate and postgraduate students who are interested in doing some meaningful projects can approach us, and we give them mentoring and training. And we collaborate with different colleges and different uh, industry partners in making the programs, in conducting workshops, seminars, and all. And institutions can also sign an MOU with us so that we can collaborate each other on research projects and also on conducting programs. So I'll show some of the programs which we did previously. You can also check in this our website on www.thecias.in. So where you can go and see the event page where you can see the previous programs. And so you can also avail the recordings of the previous programs if you wish. If any of our previous programs were of your interest, you can still purchase the recorded versions of those training programs. They are still available. So basically, we started with a course on ChemDraw and Sketch. In this, we were collaborating with Perkin-Elmer USA, and we conducted a faculty development program on online chemistry teaching tools, and another hands-on training program on ritual refinement of powder diffraction data. We conducted a 1-month Python coding program, a workshop on elemental analysis. So in this workshop, we also had a collaboration with the math software where Mr. Kurz was joined with us. And we conducted a program on console multiphysics, for which we had collaboration with NIT partner. And so we did a program on molecular docking, a training program on molecular docking, a training on Origin Pro, and a workshop. So this was not a 2-day workshop. Basically, it was a 4 days workshop on EndNote mentally and also on Zotero. So it was done. We were planning this to the this year's January, but it didn't happen. We'll still work on this international conference later on. So as I mentioned earlier, you can be a member depending upon your status of your career. If you are a faculty member, you can take a professional. You can be a professional member of our forum. Otherwise, you can be a student member. And for school students, we also have a junior student membership program. So these are some organizations with which we collaborated previously in our training programs. And these are some industry partners with whom we collaborated previously. So we are also working on some research works, and we are planning to improve our research facilities. And so right now we do not have any laboratory setups. We do things on what you can do using a laptop. But we are in near future we are planning to set up a laboratory, an offline laboratory where we can do some meaningful research programs. So we do consultancy programs for data analysis works like ritual refinement, computational analysis, and spectroscopic analysis things. So if you want to get some things done, and if you find it's too time consuming, you can approach us to get it done. We will get it done for you. So some of the upcoming programs are here. Maybe before that, I'll show you another slide. So this is something which we already did on LaTeX, and this is something which will be coming up soon. So this was previously scheduled for December 2021, but it didn't happen so far. So we are planning to make this happen with mostly in a time of 1 or 2 months. So mostly this will happen in May or June. This data analysis using R programming. So basically, this will not be restricted to R programming. This will be a program on statistical methods, and which will also include R programming. Okay. And we are planning a Gaussian software training program. So this has been offered to our participants many times earlier, but we are still not in a position to make this happen. We are still working on this. We are still talking to people. We are still contacting different resource persons to make this program happen. So hopefully this will soon happen, a training program on Gaussian. And there will be one program on molecular communication. So this has already happened, and not mentally, we already did this. Monte Carlo simulation also, we did this last week. So this was our last program, Monte Carlo simulation. So you can get the more details on the website. So we did this as well. And now there will be a training program on electrochemical data analysis. So basically a program on electrochemistry and a program on statistical methods. These are the two things which we are planning to make in the very nearby future. Maybe within a span of 2 to 3 months, both of this program will happen, hopefully. And there will be a program on molecular dynamics as well in the near future. So these are the same things which I just told on membership, all these things. So that's it. So today now I'll talk about today's program. So we already have Dr. Dilip here. So we'll be sticking to the plan that we have already shared with you. And today we already sent everybody an email with a link for those who do not have Mathematica, a link for installing the trial version of Mathematica from the Wolfram website. So I request you all to install the software. And if you have some problems regarding the installation, you can definitely contact Dr. Dilip. But I would suggest you, if it is some trouble which you find, if it is something time consuming, then it is better that you can contact us through email, because otherwise it will consume the time of the session. So please keep it in mind. And again, you will all receive a certificate after the at the end of the program. And if anybody of you need a receipt, for a payment receipt for the money you paid, you have to email us. So a receipt will be provided only to those who are requesting for a receipt. So if you need a receipt, you can just make a request to the email sparkinstituteofscience@gmail.com. Then you'll be provided with a receipt for that. So so that's it. 1 second. So today we have Dr. Dilip here. Dr. Dilip, as you already know, he did his PhD from IIT Madras, and now he's IIT Madras and National University of Singapore. He did a joint PhD by both these institutions, and right now he is working as a research scientist in National University of Singapore. So we are very privileged to have him as our resource person today. So Dr. Dilip, now it is your floor. Please take over.
Yeah, hi. Thank you, Hijaz. Thank you for your introduction. Okay, so I'm happy to be here, first of all. Okay, so let me tell you a few things before starting the class. First of all, I have a small technical problem with my laptop. That's why you cannot see me. My video, sometimes, I mean, it gets switched off. So that's why I thought maybe I will keep my video, video off during the session. Okay, so I hope that is not a problem. So that is what's number one. And by the way, like, can you hear me? Am I audible?
Yes, you are. Yes.
Okay, good. Okay, so that is number one. And then a few more things. By the way, like, how many of you have already installed Mathematica in your machines? I mean, in your laptop? Like, did you do? I mean, everyone, or do you have any problem? Because there should not be any problem in, during the installation, because that is a straightforward method, at least in Windows machines. If you're using a Linux machine, maybe, I mean, you should just follow the instructions using the command terminal. If you're using Mac also, it should be straightforward, just like Windows. So I hope at least most of you have already installed Mathematica in your machine. So what you can do is, if you have not opened it already, you can turn it on. You can, I'll just show you how to turn it on, maybe 1 second. Okay, so when I start my classes, I will just show you step by step. Okay, and another thing regarding this workshop, we are having, I think, 9 classes, I guess. And during our sessions, I will try to make my points, I mean, as clear as possible within my limited knowledge. And I will go very slowly, so that even if you are a beginner, you should not be any problem following what I'm saying. Okay, so if you have any doubts in between, kindly note it down, and we will have a Q&A session, maybe at the end of it, maybe for the maybe after the, I mean, for the last 15 minutes, we can reserve it, I mean, depending on the class. So definitely we'll have some Q&A session, at least for 5 minutes each day. Okay, so you can note down your points that you, I mean, if you have any doubts, you can note it down and ask me later at the end of the class. Okay, so, and this workshop is designed for beginners, in the sense that even if you don't know anything about coding, even if you haven't done any coding in your life so far, that is okay. Because there are two reasons for that. Number one, as I said, I will try to give some introduction about what is coding and how to code and how to use a logic for coding. And apart from that, the software that we have chosen here, which is Mathematica, is a very user-friendly software, in the sense that even for a beginner, you will not find much difficult in executing your programs, your computations, and plotting and all that. So it is, in my opinion, is one of the, maybe the simplest program, I mean, commercially available today. It's simpler than Python. It's very user-friendly in terms of the syntaxes. I will tell you like what are syntaxes. So even if you don't know these terms, it is okay for now. Okay, so that is how we have designed our everyday program from a beginner's perspective. Okay, so even if you're an intermediate person, or even if you have done some programming in some other languages like Python or MATLAB, it is still okay. Like we have stuff for you too. Okay, don't worry about it. Okay, so I think that is okay. That is a good introduction. Now I will share my screen. I'll try to share my screen once again. Okay, can you see the shared screen? Yeah, can you see it now?
Okay. Yes, sir. Yes, sir.
Okay, good. Okay, good. So I will tell you about like the way I'm going to discuss these things. So we have I have a OneNote where I can draw things. Maybe I will show you. You might have already seen all these things before, but anyway. So this is the day one. So I hope you can see this. So I'll be having discussions over this area, and this is okay. The right hand side, you can see a small black column, and this is actually my Mathematica notebook. But don't worry, I will close it and open it for you so that you will see how to open a Mathematica software notebook. Okay, so I'm going to close it for now. Okay, I will save it first. Okay. So by the way, I'm using a Mac machine. So even if you're not using a Mac machine, it is okay. So what you do is you go to your, if you are mostly, I think most people are using Windows. So go to your program, start menu, and type Mathematica. So I'm going here. So after that, you click Mathematica. So once you clicked it, you will get a new window. Okay, since I have already another window. Okay, this is what you are going to see once you open the Mathematica. I hope you have seen this window in your machine. Have you seen this? Like a white blank window where you don't see anything. Have you seen that?
Yeah. Okay.
Okay, good. So if you are here, then you have already started the Mathematica workspace. Okay, so this portion is called Mathematica workspace, this white blank page. Okay, and this is usually called a notebook, and it has a file extension .nb. I'll tell you what does that mean. So first of all, every time before you code, when you open a blank space like this, it is always safer to go to file and save it, because saving is very important. Otherwise, you will lose all the work that you have done so far. It happened to me many times. So you should make it a habit. You have to save your contents even before starting or coding anything on your workspace. So I'm going to save this as day one. Okay, so day one W. Okay, that's the name. And you can see here the format is .nb. .nb is a notebook. That is the usual format of Mathematica workspace. So every time you don't need to turn on, or let's say if you turn off all the Mathematica windows, and then next day when you open it, you don't need to turn on the Mathematica. You can just go directly to your saved notebook and double click on it. I mean, these are like very basic. I'm telling you this because I just want to, at least for the first day, I want to give you the most basic introduction possible. Okay, because I hope maybe at least one person in our group might not have seen all these things before. So I don't want to miss anyone. Okay, so I'm going to save this. So I hope it is saved. So if it is saved, yes, you can see the file name here on the top of it. Okay, now personally, I don't prefer the white color because I have some problem with my eyes. So this brightness is really a problem for anyone who code or who programs a lot. So usually I prefer a black background. So you can do that in Mathematica. It is very easy. What you have to do is you can see a few options on the top. So this is called menu. So there are a few menus like file, edit, insert, format, cell, graphics. We will look into each and every menu depending on like our usage. Okay, so we don't need to go through all the menus if it is not needed. So whenever it is needed, I will go to that menu and introduce that for you. Okay, right now my aim is to change the background from white to black. Okay, so I went to format, and then there is a style sheet option. Then it is set to default, which is a white color. Now I just want to reverse the color. So reversing the color means white to black. Okay, so this is at least some, it's good for my eyes. So if you prefer to keep white background, it is okay. It's just fine. But I prefer to keep black background for the ease of coding. Okay, so that is the first part. When you start programming, you should take care of your safety, especially your eye safety. Because from my experience, I can tell you, if you are serious about programming, if you are serious about using your computer for a longer time, then you should really consider your eye safety. My eyes had this problem because of extensive MATLAB programming for like months and months. So I did not take care much about my eyes, and that's why I had this problem. So I do not want that to happen to you. Okay, so safety is first. Okay, next thing, maybe I'll just type something. Okay, so you can't, it's just simple some alphabets, that's it. So I just typed something. That is what you should do. If you are new to some program, just type something and hit enter and see what happens, right? Because you don't know anything in the beginning, and this is how you learn. So I just typed something, and in order to execute this, I don't know like what will happen. It might throw an error, I don't know, or it might give some answer, I don't know. Like let's say I don't know anything about this program, and I have typed something and I'm going to enter. But in Mathematica, a simple enter or return. So you have a key on the laptop or your desktop, right? Enter. So if you simply put enter, nothing will happen. If you have done programming in other languages like C or C++ or MATLAB or Python, a simple enter will execute your program. But in Mathematica, it is. When I learned Mathematica for the first time, I learned it myself. So I spent at least 1 hour just to find out like why it was not running, because enter was supposed to run the program. So that was like many years back, 10 years back. So that time the documentation was very, it was very poor. So I was like very much struggling with myself just to enter or just to execute a program. Okay, so you can just check it. If you have already opened your notebook, just type something and just enter. Nothing will happen. So in order to execute in Mathematica, what you have to do is you have to click Shift and enter. So I just clicked Shift and enter. Then you can see a few things. But okay, now the another problem. This font is too small for my eyes. I think it is too small for your eyes too. So I want to increase the font. So on the top of it, you can see the font size, which is 100% by default. Now I am going to increase the font to 200. Okay, now it is okay. I can see something. So I hope it is readable now for you. If you are using Windows, this option is not on the top right. It is bottom right. So you can go to the bottom right side and increase your font. I always suggest to increase your font according to your convenience. Okay, so I set it to 200%. So everything is okay. Now let's analyze one by one. So what is the first thing you can see here? So can you see my cursor? I hope you can see my cursor. Here it is, right? IN and then a square bracket 188, then some 2 dots, and then equal to symbol. So this is nothing. This shows that this is your IN, means input. 188th input. Okay, it's supposed to be the first input, but then I have done some other mathematical calculations today before. So if you are using it for the first time, then you should get a number 1 or 0, depending on the version of your Mathematica. So that doesn't matter much, but I'm just introducing you. What does this mean? So this is your input. Okay, so this part is your input, and out, you can see out here, and the output is this. So I typed something and I got some output. Okay, so here on the right side, you can see something, some small square brackets here. So when you click here, you can click first square bracket and second square bracket. And then there is another square bracket that includes both of these square bracket, 1 and 2. Okay, so the first square bracket selects all of your input. This square bracket indicates your input data. So even if you have, let's say, some other, I just clicked enter, then I type something else, then I can shift plus enter. Then you can see that if you click it, you basically select all the input. So this square bracket indicates all the input, and when you click it, you select everything. So after you click it, you can maybe you can just copy it using Control-C. I just copied it, and then come down. You can see my cursor. You have to see my cursor all the time. This is very important. And come down here and click somewhere, and again Control-V, which is paste. Okay, then again hit enter. Okay, so what I did was, usually we copy the entire text, right? That is how we usually copy. But in Mathematica, when you go for a long input, which will, I don't know, maybe thousands of, when you, I mean, slowly, if you start writing, you will have thousands of lines very easily. And when you do that, it is very hard to copy the entire block. So using this input cell, you can simply click on it and copy the entire block of input and use it for your other purposes. Okay, so in the same way, you can use the output cell, and when you click the overall cell, which is this includes both input and output. Okay, so if I want to delete it, I have selected the entire input and output cell and click delete, so it is deleted. Now again, there was another, the second one which I copied. Now I'm going to delete that too. Okay, so you can test all this. You can play with this and see what are the things that you can do. Okay, so I hope you have understood the basics of it. And one more thing, let me type something else. So these are called cells. I don't know like whether I have introduced it. So this thing is called cell. This is called input cell. This is called output cell, and this is called input output cell, which includes both input and output. Okay, so that is all about. So now you know how to enter an input and how to get an output. Okay, so anyway, the ones that you have typed doesn't make any sense, but I just wanted to show you what is input and output in a Mathematica. Okay, so here maybe you can, if you are interested, you can go to after selecting, you can select in both ways. Either you can select part by part, or you can select the entire input, as we already discussed. So I have selected only this text and went to maybe you can format, you can change the style here. You can set it as here you can see that by default it is input. So that means Mathematica is not only for coding. Okay, so many people think that it's designed for coding. Of course, it was originally designed for coding, but you can use Mathematica for different purposes, like for presentation. Usually we use PowerPoint, right, for presentations, but Mathematica can be used for presentation. You can use titles, subtitles, you can create chapters and all that. Okay, so we are not covering any of it in our workshop because that is beyond the scope of it. We'll only stick to the coding part of Mathematica. So the point is, if you select a text or select a piece of code, you can always change. You have a lot of options here. For example, you can set it as bold. By default, it is bold or italic, or you can give some underline. You can even change the text color if you want and the background color. But I'm not going to change anything because I just want to set everything as default as possible. Okay, but there are many options you can play with. You can play around with all that. Okay, so now we know how to give an input and we know how to get an output and we know we can format it. Okay, now we will, let me open my OneNote. I hope you can see this. So first of all, let me tell you what is the logic of coding. Like, why do we even need to code, right? So people usually, you might have seen many people writing day and night, I mean, pieces of codes and getting results and getting frustrated about it. So what is the reason, or why do we need to code at all? Do we really need to code? Maybe we can get a pen and paper and do some computations, and maybe that is enough for some time, right? The reason why, in my opinion, there are of course many reasons why we need to use programs or different languages to code. So I can think of a few very basic reasons. Number one, it makes our life easy. Let's say you have a differential equation. Okay, and a very simple differential equation. You can think of any simple differential equation. And let's say you know already how to solve this differential equation and get a solution. But what if you have, let's say, I don't know how to read this, you can read it later, this many number of differential equations. What if you have this many number of differential equations to solve and you have no time? Let's say you are restricted or you are asked to solve these many number of different differential equations in one day, let's say in 25 hours. But you know how to do it, of course, one by one, but definitely you are going to take a lot of time, more than 24 hours. In that case, of course, you can rely on a computer program, and write down this equation and solve all these equations very fast. There are many ways of doing it. So one reason for coding is it makes your life easy. You can do tasks within a short period of time, because once you tell the computer that how to do something, then it can do it like for ever and ever. Because once you code a computer in a language, coding a computer in a language means it's like you are telling someone to do something, right? Maybe if you need a help from your friend, usually what you do is you will call your friend and ask him to do something, right? So your friend does that. Just like that, every computer program, whether it is a C or C++, Fortran or MATLAB, Mathematica, Python, R, or any program, it is there to make your life easy. Okay, and it saves a lot of time. So that is why you need coding. So this is the best reason. There are many other reasons, like this is the simplest reason that I can think of now. But coding has evolved a lot recently, so that we use coding for different purposes. Like let's say there are things that we cannot do it within a short span of time. Let's say you want to predict the climate. So climate prediction, you know, it's not an easy task. You cannot do it using a pen and a paper. You need a lot of information. There are several variables like data from atmosphere, the humidity, the temperature. So there are many factors that is going to affect the climate in the next minute or tomorrow or next day. So, and what you need to have is a kind of model that takes all these variables like temperature, humidity, and all that data, and this model executes, or it takes all these variables and gives you some output. So it's like you have a model and you have many input, and finally this model give an output. Okay, so you can do this even by hand, but then, as I said, difficult problems like problems that requires extensive amount of time and models that are too complex to solve numerically or by hand, you have to rely on some programming languages. So that is why we need all these languages. And Mathematica, in my opinion, is one of the easiest program to learn and of course to forget, because it's easy to learn and easy to forget. So it's not like other programs. From my experience, I found that learning MATLAB is not very easy, at least in the beginning. The learning curve is a bit steep. But Mathematica learning curve, it is very smooth. You can learn things very fast. Within 10 days, you can maybe kind of master in your field. But if you don't use Mathematica, or if you, especially Mathematica, if you don't use it for a while after that, then you will forget everything. You'll forget all the syntaxes. You might even forget how to, I don't know, maybe I'm just exaggerating, maybe, but you will forget most of the things. So the things that are easy to learn are the things that are easy to forget. So keep that in mind. So when you learn a language, you always have to refresh yourself. Even if you don't need it, at least once in a week, just type something and have some fun so that you refresh yourself. You don't forget things. Okay, so that is another advice I thought worth giving. Okay, in Mathematica, just like we have already seen, we have inputs and corresponding we have output. Okay, so for serious problems, of course, we will have some models or functions. So I'm going to use another word. And functions, as you know, we will see functions, all that later in details. Okay, what's happened? Okay, so these are the two reasons I thought worth sharing, and you can think of other reasons later. Now I'll tell you how to code, or the original question in our hand, which is logic of coding. So the natural question is it possible for everyone to code? Or as a human being, are we supposed to code? I mean, are our brains are capable to do some complex coding? Or some people ask, like, I don't know, like whether some people told me a few years, I mean, when I was supervising some project students, they usually tell me coding is very difficult and they cannot learn it. I usually reply that you cannot say something without trying. You cannot conclude without trying. So the people who say that coding is difficult are the people who sometimes, or most of the time, they don't even try it first. So they hear some opinions or advices from others who have failed it, or again, who might not have even tried. So they somehow conclude that they cannot code. But in my opinion, if you're a human being with minimum average capacity of brain, you should be able to code pretty much neatly. Because what you all need is logic, right? If you are given with some, let's say, pieces, if you know how to solve a puzzle, or if you're good at solving puzzles, then you'll be good at solving, programming problems. Even if you're not good at solving puzzles, still with Mathematica, you can solve pretty much decent problems very easily. Okay, I'll tell you why I'm saying easily many times. We'll see that later. So let me explain the logic of coding. So this is again very a common sense thing. I will only cover all these things in the first class from the beginner's perspective. From tomorrow onwards, we'll have some serious discussions. Okay, so the question is how to code, or the logic of coding. Let's say you have an experimental data from an oscilloscope. So this is a text file. you know what a text file is. So this text file has two columns of data. Let's say it has some, let's say some input or output. Okay, let's say you don't have output. Let's say this is input 1 and this is input 2. So you have two input. Okay, and it could be any variable, some two variables, maybe voltage signals from two channels. So you have a text file with many rows. Let's say you have some 100,000 rows and only two columns. Okay, now you want to do some calculations, or you want to apply some function on these two input and get some output. So you know the model already. Let's say you already know the model or the function to be used. So for example, let's say this is length data. I'm taking an example. Length data, and this is, let's say, G, which is acceleration due to gravity, 9.8 meter per second square. Okay, which is constant, of course. So you'll have 9.8, 9.8, 9.8 all over. Okay, so this data, of course, this text file is originally from a simple pendulum. Let's say you have an oscilloscope connected to a simple pendulum. Okay, so simple pendulum is a hardware, and oscilloscope is used to extract the signals such as length and acceleration due to gravity. Let's say you have done it. Let's say you are very smart and you have done it. Okay, so now you know what is a time period corresponding to every length and G data. So you have many lengths, you have tried many length, and you want to know what is the time period. You haven't measured it, but you want computer to tell you what is the time period. So for that, you need to use, of course, number one, you need to use this text file. You need to import this text file. So that is the first step. So when I say logic, or when I say how to code, it is just common sense. So first of all, if you have a text file, just copy to your computer, import to your language, your preferred language. If it's Mathematica, okay, we'll stick to the Mathematica. So we have to import this text file to the Mathematica. That is step 1. Okay, and step 2 is you have to extract each and every row for the computation, right? Extract rows or extract data in general, and set these data as, variables, some variables. Okay, so I'm telling all these things in general. So when I say variable, it can change depending on your problem. Okay, for example, in this case, you can set a variable L as your first column, something like this, and the other variable G, you can call it G as the column 2. Okay, so basically these are like first column like this, and second column like this. So this is your L data and this is your G data. So you have already extracted this data. Now, after extracting this data is available for Mathematica. Okay, so you have to make it available. So we used extract function, or we just extracted it in order to make this data available to the Mathematica desktop for further computations. Okay, so we have already made it available. Okay, then you have to apply your function or model. For example, if time period is what you are trying to compute, then you have this equation already. So what you have to do is you have to use every row from these columns and plug it in here, and then compute T, and then set the answer or the output. So this is T is your output here, and set output as another variable. maybe just following our previous case, maybe I will set this t as our output variable with a column. So every column, every row in this column indicates the corresponding time period. Okay, and then you can finally show the result. Okay, so this is the applying function part, which is the computation part. Okay, so this is just like this figure over here. So you have some input, and then you have given this input to your function or model, and then you have got some output, and finally you have to tell the computer to show the result. Okay, sometimes if you don't tell the computer to show the result, it won't show it. Okay, so this is the common logic or the common sense of every programming in every language. Okay, so this is very simple. I hope you all understand this, all these steps, because this is how we think, right? This is how we think even in our other problems in life, right? Step by step. So the one advantage of programming is, I think I have seen that some research shows that if you do programming extensively, it can help you to think in a better way. I mean, reasoning and your logical skills will be enhanced over time. Okay, so you can make better decisions even in your life, not just in programming. Okay, so that will give some progress to your brain part. So I hope you all, I mean, at least try to do this kind of, brain exercises. Okay, so now we know how to program, or we know some basics about the logic behind the programming. Now let's get into the real life problems in Mathematica. Okay, let me delete it first. Okay, so okay, let me add two numbers. So how to add two numbers in Mathematica? So this is my input. I have already shown you the input cell. I have just set 2 plus 2 and then shift plus enter. So 4. So this is how you get input. I mean, you get the output from an input. So this is very simple in the sense that in some languages, you have to set 2 as a variable, like variable 1 is equal to 2 and variable 2 is equal to again 2. And then you have to say that variable 3 equal to variable 1 plus variable 2, and then show finally variable 3, something like that. So this is the usual. So 4-step programming in many of the languages, especially low-level languages. Mathematics is a high-level language. When I say high-level language, it means it's very user-friendly. So you can see that this 2 plus 2, which is it is like you are writing it on a paper, right? You don't need to know any complexities that is happening behind the Mathematica engine. Okay, so Mathematica is very convenient and easy in that sense. So inputs are usually much better to enter in Mathematica, and the syntaxes, I will tell you what syntaxes are. The syntaxes in Mathematica are very easy to remember. Okay, so now I'm not explaining like why or how Mathematica has developed such a high-level language. I'm not going into the details of it. We'll stick to the user part. Okay. Now, maybe actually instead of 2 plus 2, we can still do something like I'm setting x as 2. Okay, so now I'm setting a variable x as number 2. Okay, then I use this semicolon. So semicolon is usually used in Mathematica to suppress this output. Okay, let's say if I simply now click enter, I will get 2 as output. But if I use the semicolon, I get nothing because the output is suppressed. So semicolon is used to suppress the output. So I have suppressed that line of output. Then I'm setting y as again 2. Okay, then I'm setting z as x plus y, and I suppressed it. Then I just click set. Okay, maybe it's not needed. Okay, so what you can see is that x equal to 2 is suppressed, y is equal to 2 is suppressed, only x plus y is shown as output. Okay, so here we have just followed the way that we usually adopt in other programs, like we have set variables and then we finally, this is our model. X plus y is the function or model, and that we set it as a set. And then we finally got, because we haven't suppressed this output, so we got the output set. Okay. So we have already set some variables here, x and y. Now, if you want to go to a fresh cell, this is your cell, input output cell. Now, if you want to create a new cell, you just go down, you click your cursor somewhere here, anywhere here. Then you are in a fresh cell, fresh input output. Okay. So for Mathematica, the one advantage is that once you define your variables throughout your workspace, that variables are going to be constant unless you rewrite it. For example, let's say if I want to know what is x, then I just simply type text and just click shift plus enter. So meaning the Mathematica is remembering all these variables behind. For example, if I want to know what is y, because right now I am in a fresh cell, right? This is my fresh cell. It has no dependence to the other cells. Okay. But that's the point. Even if you are in a fresh cell, where all the variables are stored. But this is sometimes confusing. Let's say if you are using a single notebook for different types of calculations, and then these variables can get mixed up, and that will confuse you. You can never find what is your problem, because maybe you are having 1,000 lines of code and you don't know like where the problem is. So in my opinion, in that cases, if you think you are mixed up with variables, you have to remove all the variables. How to remove it? So this is the syntax. Okay, now I can tell you what a syntax is. So before that, let me tell you, Mathematica has more than 6,000 inbuilt functions. So when I say function, I mean something like this. In English word, remove, expand, all these are function names in Mathematica. And all these functions are followed by square brackets. Okay, so that has to be, you have to remember this, not curly parentheses or curly brackets, but square brackets. We can see that there is a small red arrow here that indicates that something is missing, meaning the function has no argument so far. We haven't given any arguments. You can see here, you can read it here. Too few arguments given for remove function. Okay, so that means this function requires an input. You cannot simply tell the computer to compute something without giving input, right? So you need a function and you need corresponding inputs. So in this case, you need to write something inside it, inside the remove function. So I'm going to write something, just follow it. I'm not explaining it, you can just simply see what I'm typing for now. Okay, so I have written something inside the function, but then to, you know, so we have written, okay, so global, and then another sign, and then another star symbol, and which is within this inverted commas. Okay, so double inverted comma. So when you do that, so you can maybe remember this this entire line as such. This is the command to remove all the variables which are stored so far. So I hope it has removed it. So let me, okay, so now you can see that last time when I entered x, I was given with 2. After removing all the variables, after removing the variables using this command, x gives x, meaning x is now free of any numbers or any variables. Okay, so you can simply by heart this if you want to remove the variables in between your programming. Okay, so that is very important. Okay, so now you know how to give input. This is the standard way of giving input. Okay, you have input and output. But in Mathematica, unlike other programs, there are, as I said, it's a high-level program. So we can give input in different ways. I'll show you. So you have an equal button, the equal key on your laptop, right? Plus and equal key. So if you click it once, you will get something like this. And if you click it again or 2 times, it will be converted into something like this. What does these do? These two are called free-form inputs. Maybe you can write it down. These are called free-form inputs. This requires, first of all, a good internet connection for this to execute. I'll tell you how this works. I will show you how this works. Okay, let's say I want to get a picture of a zebra. Okay, so how to get it? So I'm just telling the Mathematica, get me a picture of a zebra. Okay, I have to wait for some time. Okay, so see, I got the picture of zebra, right? So I don't know like where this is coming from. Maybe Mathematica has a huge collection of database with all these different pictures, or it is fetching some random picture from internet. Okay, so the way it works is not our concern for now, but this is very powerful because even if you don't know anything about programming, you just showed a picture of a zebra randomly.
Sorry, it's not visible.
Sorry, what?
It's not visible. Zebra is not visible.
Really? Okay, it's visible here. Okay, let me see what's the problem.
And now it is visible.
Okay, now it's visible. Now it's visible.
Okay, good. So you have a zebra in the sense that you can get any picture or you can type anything that comes to your mind. Maybe you can just tell for the weather forecast tomorrow. Okay, but before that, let me play with the zebra. A few more things. For example, let's say if I want to detect the edge of the zebra. So how to do that? So maybe I will use my free-form input again. And there's a function in, again, Mathematica called edge detect. Okay, so I just type it here and then picture of zebra. So this is how I am going to introduce all the functions. Okay, I'm not going to introduce all the functions and then dive into the programming. We use the functions one by one depending on our need. Okay, so let's see whether I can get something out of this. So this is running here. Okay, it seems that there is no interpretation available here, which is kind of, you know, not very good. Okay, let me try a different way of doing it. Oh, okay, so this works. So you can see that this is the same picture as before. Okay, but this time only edges are detected. So I was just simply plainly typing some English words like edge detect, picture of zebra. So Mathematica is very intelligent such that it knows like what I mean. Sometimes, of course, it doesn't know what I mean. So in that case, you have to change it. For example, last time I deliberately put some, you know, square brackets and Mathematica couldn't interpret it properly. So the point is, whenever you are using free-form inputs, you have to be as simple as possible. You have to keep things simple. You avoid all those symbols, numbers, all that if it's not needed. So keep as if you are asking some friend to do something. Like, so let's say, what if I ask a friend to edge detect the picture of zebra, right? So something like that. So keep it as simple as possible, especially when you are using free-form input. Okay. Now let me introduce the next free-form input, which is something like this. Now what to do? Okay, let me ask Mathematica to predict the weather. Okay, so weather tomorrow. I want to go someplace tomorrow and I want to know like what's the weather. Okay, so you can see here. So the input interpretation is weather forecast, and it is tomorrow. And you can see all the details here. Tonight it is of course 26 degree and clear. Actually, it's not clear, it is wrong. But tomorrow, let me see, it shows it's clear. Okay, raining in the late morning onward. Tomorrow night, okay, you have the details. And you can see it has fetched some graphs from somewhere, from some database, and you can see all these details like your temperature, past temperature and future temperature, and the cloud cover and the conditions, and your wind speed and the historical temperatures and all that. So what is the difference in using this square input and this star input? So the main difference is whenever you use a star input, it will give you more details. It will tell you step by step, or it can even tell you the details that you don't even need it. So if you need a detailed interpretation of your input, you go for the star freeform input. Otherwise, if you just need something simple, something that is suitable for your need, just go for the square freeform input. Okay, so let me try something else just for fun. I want Mathematica to plot, let's say, sine xy. Let me see. Okay, so it is doing something. Oh, okay. Okay, so we have some good three-dimensional plots here. You can click over these figures and rotate it and see from different perspectives. So this is nothing but a sine xy figure. So first of all, I have to tell you, the Mathematica has interpreted this as sine x times y. So this is not sine xy. So I want sine xy. I ran it again. Okay, now you can see that this is sine xy. This is how the Mathematica has interpreted my input. So you have a different three-dimensional picture here. You can rotate it, you can play with it. Okay, so you have a corresponding contour plot. So I hope you know what contour plots are. And so you can see some handles over here, some controls over here, and you can change the x minimum. When you change the x minimum, you change the plot region, because usually it plots from, in this case, I think it is by default it is plotted from -3 to 3, but you can change all that over here and see how it changes. Okay, so you can change all that. So that is those are the three different ways of using Mathematica for input recognition. So during our course, we are not going to use freeform inputs because we want to do stuff. We want to learn this software, right? So we will stick on to our conventional way of giving input and output. Okay, so by the way, do you have any doubts? Maybe just 2 minutes. If you don't have any doubts, then it is okay. So I will quickly go through a few more stuff, like different. Yeah, you have any doubts?
Sorry about plotting that.
Yeah, this
Plotting
one,
the
right?
graph.
Zebra, okay.
So no, that graph, sine xy one.
Okay, graph. Okay. Yeah.
Okay. Then we don't need to put any like bracket or third bracket or something.
No. That is way it is designed. So whenever you are using free form, you don't need to stick on to any syntaxes. Okay, but you can still plot this sine xy without free form input. In that case, of course, you have to follow the certain rules like syntaxes, brackets. You have to be very much, stick on to those rules. Otherwise, you will get errors. We'll see that. We'll see that in the. I think tomorrow is the plotting day, so we'll see how to plot, how to use all those syntaxes tomorrow. Okay.
Okay.
Okay, good. So coming back to the important part. So you have seen there are three types of parentheses or 3 types of brackets, like square and curved and curly bracket. You can see all these 3 here. So these are the main 3 different types of brackets we use in Mathematica, and you cannot interchange these. The functions are very different. So you have to learn all these simple things so that you don't get confused later. So I'll just simply quickly go through this. First of all, I told you, right, Mathematica has different, more than 6,000 inbuilt functions. A plot is one function. Plot, when I write plot, it is a function in Mathematica, inbuilt function. So every function requires an input or an argument. So after function, you always take the argument within the square brackets. Okay, so that is where we use the square brackets. So square brackets always come along with the function. So next one, this one, the curved bracket. So curved brackets are usually used to group arithmetic expressions. Let's say you want to do like 2 into 3 plus 3, something like that. So usually if you give this input, it's like 2 into 3, which is 6, plus 3 is 9. But what if I want to add these 2 first and then multiply? Right, 3 plus 3, 12. So this time we used what? The curved brackets. So if you use some other bracket instead of grouping, for example, let's say if I use this curly bracket, yeah, it worked, but in a different way. I'll show you, like this is called a list and we are not going to it. But if you just need a number, the answer that you usually look for, if you need that, then you have to use this kind of curved brackets. Okay, the curly brackets, when I used it, it throwed a list, and we'll see what are list later. It's not a topic for today, but curly brackets are usually used to group arithmetic expressions. Okay, now as we already seen, these brackets are used to create a list of elements, list of anything. Let's say I want to have a list of numbers 1, 2, 3, 4, 5. Okay, so this is a list. So all these lists are defined using this bracket. So you can actually have some other numbers or strings. These are called strings. Okay, so words are called strings. So a list, usually it can contain different types of input data. This is a number. This is one type of data. This is a word, which is another type of data, which is a string type of data. So Mathematica is very versatile in the sense that a single list can contain many types of data. Python cannot do that. If you want for example, in Python, if you need a list of numbers, you have to create a list of numbers separately, and you cannot add let's say another word to that list, just like what we did. If you did something like this in Python or MATLAB, it will always give you an error because they are not capable of handling all that. But Mathematica is much more advanced and easy in the sense that it can handle all these things, and it knows like which is which. Okay, so this bracket curved, this type of curly brackets, they are used to create a list. Okay. So these are the 3 different types of brackets I thought I would share with you. And then we will go into some functions. Okay, today we will just see some simple functions for numerical computations and symbolic computations. So what are numeric and symbolic computation? I'll just give you a very quick introduction. Okay, so let's say you have a quadratic equation, ax square plus bx plus c is equal to 0. This is a quadratic equation, and you know the solution is minus b plus or minus root of b square minus 4ac by 2a. Okay, so this is the solution of this equation. Mathematica, let's say let's say you don't know how to solve this. Okay, this is the worst case, but let's say you don't know. And you want Mathematica to solve this equation for you. Okay, but then usually in every other language, even in MATLAB or Python, if you want to solve an equation like this, it is simply not possible. It's because that particular language doesn't know like what is A and what is B and what is C, and doesn't know what is X. It knows what is equal to and it knows what is 0. Okay, but A, B, C, we haven't given any numbers so far, right? These are just variables. So it doesn't know, for example, Python or MATLAB doesn't know what is a variable if they are not defined. So in this case, Mathematica can save our time in the sense that even if you don't define what is A or what is B or what is C, it can do a symbolic calculation considering these A and B and C as variables, and it can directly give you this solution. Okay, so this is something which I find very useful. MATLAB, I think recently they have launched symbolic calculations without giving input. Of course, these days you can solve similar equations even in MATLAB. But Mathematica, if I'm right, I think Mathematica is the first software that introduced this idea of symbolic computations. Okay, so these are called symbolic computations. You just need symbol. You don't need to define any variables or constants for the computation part. Okay, so numerical computation, on the other hand, it's just like the ones that we do usually in other programs. For example, you have to define what is A, and you have to define B and C. And once you define, of course, you will get some a number, right? Maybe +5 and -3, something like that. You will get this number as a solution. Okay, so solutions in the case of numerical computations are always going to be some numbers, but symbolic computation solutions will be some expressions. Okay, so you can use these expressions to and insert all these numbers later, constants later, and you can make use of this expression later. That is a different part. But this is the idea of what a symbolic and what a numerical computation is. Okay, so there are functions in Mathematica to do both symbolic and numerical computations. Okay, so let me introduce a function called n. N is a function for numerical computation. So I will tell you what it means. So I'm just placing 3 plus root of 2. Okay, and okay, I'm not using that over here. Okay, I have something interesting to tell you, but let me finish it. Okay, so first of all, this is the way that I've written here. You can see that you don't see such simpler representation in other languages, right? For example, if you want to use a square root, you have to type sqrt in Python, even in MATLAB. So Mathematica is so powerful such that you can use some shortcuts in the keyboard to get a much more appealing way of representing your equations, so that you don't get confused even after years. Because I remember, like, when I was doing some coding in MATLAB long back, after a few months, I would be completely in a messed up position that I don't know, like, where are the brackets and what are those functions, and it's really difficult to follow up. But Mathematica, since we can represent all the inputs in a much more simpler, readable way, we can always look into it, and the understanding is very easy. Maybe I can tell you how to input the root symbol here. So control +2 is the root, square root. And control +6, the number key 6, is for representing the power. Okay, so you can try that at your free time. But let me try with this. So, okay, what I have done was I have given some expressions inside the function n, and I have given with a number. I'm given with a number which is 19.4853. So what it does is this numerical function n takes this input and calculate it and give you a decimal number, give you a readable number. Okay, so n is to understand what is the numerical value of your input. Okay, so this is to get the numerical value of input. Okay, and another thing, if you want to add comments in the line, in the command line, you use something like this. You write your command within this bracket star and again star bracket. Okay, this is how you comment or add comments in your command line. Okay, so now you know what is a numerical function is. Okay, now there is another function. This is very easy, so I will just skip all these things very fast. So just like okay, I will go to the symbolic expression later. Let me solve an equation for now. Okay, so solving an equation, so that takes a function called nsolve. Whenever you write something, Mathematica will give you some suggestions and you can select that syntax from the suggestions. So you don't need to remember all these functions. Okay, so nsolve, let me show you how this nsolve work. Okay, so nsolve is a function which is used to solve an equation. That's it. Simple for simple equations. In fact, not for differential equations. Differential equations, you have another function for that. But for simple equations like algebraic equations, you can use it to solve it. So I'm going to solve an equation like sin x equal to 1/3. That is my my equation, and solve it for x. Okay. So nsolve takes two input. Okay, let me write it here. So I will write it only for once, and after that you can follow it. So for every function, in this case for nsolve, it takes the first input or the first argument as your equation. You have to put your equation, and you have to tell you the variable with which it has to be solved, the variable for which it has to be solved. Okay, so the equation, how to write an equation in Mathematica? Usually we write sin x equal to 1/3, right? This is our equation by hand. In Mathematica, you have to write sin. Sin is a function, so you have to use this square bracket and x inside. And instead of 1 equal to, you use 2 equal to. Okay, so this is how you define a equation in Mathematica. So this is what you have to look for, this part, 2 equal to, and then 1/3. Okay, and one more thing I would like to tell you is that for every function, most of the functions start with a capital letter. So if you type instead of a small letter like sin x equal to 1/3, it will give you an error. So that means Mathematica is case sensitive. This is very important. Sensitive, okay. So you have to know where to put capital letter, where to put small letter. And that by practice, you will get to know it. So you don't need to worry much about it. And for functions, you have, whenever you type it, as I said, it will give you some options and you can simply select from those options. But keep in mind that all the input that you are given, especially the functions, are case sensitive. Okay, so that's why you can see that N is a capital letter, S is a capital letter. If S is a small letter, it will give you an error. Okay, so you can try that. So I'm going to define the function over here, 1/3. This is, how did I get this number? Control plus hash or the question mark symbol. You can try that. Now I want to solve it for x. Okay, so this is my answer. So x has, two different solutions. Sin x is equal to 1/3. Basically, these are complex solutions. So you can see that this is the first solution, and this is the next solution. Okay, so C1 belongs to integers. It can be any integer. So basically, this is the solutions are complex numbers. Oh, one second. No, these are not complex numbers. Sorry, I thought there is an I here. So basically, what it says is, as long as C1 is an integer, and you can substitute that integer here, and you will have many solutions, like 0.33 plus 6.2, something like that. So usually by hand, it is very hard to get these kind of solutions. Mathematica give you a broad general solution, and even after giving a general solution, sometimes you have to use your particular application in order to extract the exact number that you need. Okay, that varies from situation to situation. So Mathematica will always give you the most general solution. So let's say I want to solve a simultaneous 2 or 3 number of equations simultaneously. So in that case, the same and solve. So what I'm doing is numerical computation. Okay, so this is something that you have to keep in mind. I'm not using symbolic calculation so far. I'm just using numerical computations. Okay, so n solve. So let's say I have 3 different equations. So if I have more than one equation, I have to group all or create a list of equations. In this case, as you can see here, let's say if I have an equation x equal to 3 or y equal to 4 and x plus y equal to 23. Let's say I have 3 equations and I have to solve these 3 equations simultaneously for both x and y. I want to extract what is x and y satisfying these 3 equations. So in order to do that, we know numerically in order to get that equation, you have to use n solve, right? And you have to use that big square bracket. And but then the difference is, if you have more than one equation, you have to consider or set it as a list. Okay, so again, all these rules, just try to remember this, but over time you will be used to it. You don't need to remember it forcefully. It just simply comes. So you need to have a practice of where to use list and all that. So that's basically common sense. You will get that common sense slowly after a few days. Okay, don't worry about it. So the code is going to be like this for this particular equation: y equal to 4 and x plus y equal to 23. Okay, so closed bracket. And then I know, right, I have to solve it for both x and y. So since again I have 2 different variables here, I have to use a list. Okay, so when a list is created, nsolve takes one argument. This is your first argument 1 and argument 2. You know why? Because nsolve can only take 2 arguments. If you have more than one equation without these brackets, let's say if I remove these brackets, then I have, this is the first argument, second argument, third argument. But if you give more than 2 arguments, nsolve doesn't know like what to do. So it will give you an error. So in order to keep these rules, we have to set all these equations as a single argument. And that is why we created a list of all these equations. And after creating it, nsolve can consider that as a single argument. So this will consider as the argument 1 and then argument 2. Okay, so that is the logic behind creating this list. So right now, let me create the first list: x plus 2y, okay, plus 3. Okay, so this is going to be a bit more complex. I want Mathematica to do something harder for me. Okay, so 3x plus 4y, 3x plus 4y. You can write along with me, it is fine. YZ, okay, equal to 6. Okay, next one, 7x plus 7x plus 9y plus 8z equal to 10. Okay, so I have three equations. Now I need to solve it for both x, y, and z. We can see that both all these three equations are solved simultaneously, and the solution is this: x equal to -1, y equal to 1, and z equal to 1. So this is pretty much neat in terms of giving your input and fast in terms of getting your output. Okay, so there are many functions, and if you want to know or explore more functions, you can go to help, and okay, you can simply search here, or you can go to Wolfram documentation. So you get some function here. So let's say if you need some, okay, I'm just typing something, a function name, and sum. So in sum, if you, for example, this is a function and the format is given, I mean, syntax is given, and examples are given here, how to give it and what to expect, and what are the possible errors. You can see all that here. You can see the scope here. So for every function, Mathematica is documented very well. So you don't need to worry much about it. Even if you don't find anything or the useful information that you require from your documentation, just go to Google, type it. There is a wide community out there to help you. There are almost all the questions, all the problems that you have might have already been solved by someone else. So you can see that over Stack Exchange or Wolfram community or Wolfram demonstration projects, you can simply type in the Google your problem. So it will give you thousands of results. Okay, so I don't think that you will have any problem with any of your computations with Mathematica. In my opinion, Mathematica can be used virtually for anything, to solve anything. Okay, because it has both numerical and symbolic functions. Okay, so in order to demonstrate what a symbolic calculation or computation, instead of n, whenever there is an n, it somehow, you have to think like this. N means numerical. So n solved means numerically solved, type of thing. I mean, it's numerical solving. So without n, I hope it is going to have, yeah, it is again, it's solved. It's because variables are stored. So I don't want that. I'm going to remove all those variables. 1 second, just wait for a moment. Okay, so it is because I am going to replace this 2 with a, because I want Mathematica to, you can note down one thing here. After typing a, I just clicked, or I just gave a space. So a space means multiplication or a product or times. Sometimes or usually we give a times y, right? Ay. But in Mathematica, you don't need to worry about it. You just click a space. Okay, so that is ay. So bz. So this is again a, okay, a and b, c. Okay, so I'm deleting this for, okay, only 2 equations. Let me see what happens here. Okay, so you have an output anyway, and the output tells you that y is going to be in terms of a, b, and c, right? And similarly, z is also going to be have a, b, and c, and also in x. Okay, so this particular equation cannot be solved for all the variables simultaneously, because you need one more equation, of course, because 3 equations and 3 variables, right? I've only given 2 equations. So maybe you can add some random equation for x, one more equation, and see how it happens. But the reason why I put it here, because I want to show you how to process errors, right? When you do computations, you will usually end up with errors. So errors are usually, or suggestions are usually with some red color over here. And if you click it, you can get, you can copy the message, or you can show the entire message. You can do all that. So here it will give you a indication of what is missing here. It tells you that equations may not give solutions for all variables, all solved variables. So in order to get some neat output, let me pick one more thing, maybe the final one. Solve. Okay. Let me give some hard problem to the Mathematica. Okay, control root x plus e times x raised to 1 equal to 5. Okay, now I have to solve it for x. Okay, here you can see that this difficult equation is solved for x this way, right? So it is computed, let's say instead of 3, if I put 2, sorry, if I put a, some variable or some constant, whatever that is, and b here, then still I can get it, right? But this time it's a huge output. So this is, so you can see that it's not, yeah, it's n now. Okay, so you can see that in terms of a and b, this equation is going to be very difficult to solve by hand, right? I don't think that anyone can do this by hand. Even if you try it, you'll end up with a lot of errors. But Mathematica can follow up with all these errors. I mean, it can take care of all these errors and finally give you a neat, good expression on what x might be. So there are how many solutions? I think this is the first solution. This is the second solution. This is the third solution. Okay, so there are 3 solutions because it is x raised to 1 by 3. Okay. So these are the, so what we have just done is a symbolic calculation. So whenever there is a symbolic calculation, you should not use n. N is only reserved for numerical calculations. So other functions that you can try is I just write down here and sum, and what else, like minimize. So these are the functions you can try today after this class and see how it works. You can go to the documentation directly and type these functions and see how it works. You can come up with some neat solutions. So you have to understand all this. Simplify. You can okay, so and then yeah, minimize and minimize. Okay, good. We are good now. So we have covered some basics of Mathematica today, and I hope you might have grasped some details about Mathematica, especially if you're a beginner. It would be useful, I guess. So tomorrow we will directly go into plotting, and we'll plot some functions, like some interesting functions like electrostatic field. That will take some examples from mathematics too. So tomorrow will be a bit more oriented to the application part. So if you don't know, I suggest you to read electric field and how to plot it. Electric field of simple charges like -2 charges, because that is an example that we are going to cover tomorrow. Okay, so it would be better if you have some background information about it. Okay, thank you. Yes, I think someone has raised a hand. Do you have any question?
Yes, sir. Please show. Just now I have finished my installation of Mathematica in my desktop laptop.
Okay.
So I am using here product trial, Mathematica product trial. Okay. Please show a simple this example. This 2 plus 2. I'm not getting over here in my laptop.
Can you share your screen and maybe I can?
Okay, just a minute, because I'm operating from the mobile phone. And also I have started this laptop. Just a minute, give me 1 minute.
Okay.
To laptop and then share this.
Analta है.
Yes, sir. I am. Hello, am I?
Yeah, hi.
Hello, am I audible?
Yes, of course.
Okay. Let me share my screen.
By the way, do we have a WhatsApp group for this? Maybe you can post your screenshot there, and maybe I can try to help you there.
Yeah, we'll be having a WhatsApp group by tomorrow. So maybe.
Okay, then I think that will be better.
Yeah.
I mean, okay, my opinion is after installation, you can just simply restart your entire system first of all and try all this. Okay, I mean, it should work.
Hello.
Yeah.
Is my screen visible?
Yes.
Hello.
Yeah, it's visible. Yeah, go on.
Okay. So here I have to type in now. Okay.
No, don't write in. That's not required. Just type 2 plus 2. Let me see. Just type 2 plus 2.
2 plus 2 directly.
Yeah, directly. And then shift plus enter.
Shift
Plus enter.
Shift plus enter. Okay.
Yeah.
Okay. Thank you very much, sir.
Okay. Yeah.
Okay.
Okay.
So let me stop my sharing.
Okay. Good. Yeah. So if there are no other questions, if you have questions, you can discuss that in the WhatsApp group tomorrow and post your screenshot. And even, maybe I'll be late sometimes to answer because of some other reason. But just wait for some time. Okay. So I will definitely get back to you. I know the answer. Okay. Yes. So I think.
Sir, thank you so much for presenting it from a beginner's point of view. Thank you very much.
Yeah, I think that is all for today. Yeah, he just.
Thank you, sir.
Yeah, thank you, Dr. Dilip. And for the participants, we will share you the recording of today's session with all the participants by email. Mostly maybe by tomorrow morning. By tomorrow morning, you all will receive the recording of today's session, so you can practice it again and again. And whenever you have a doubt, you can look at the recordings again. And if you still find difficulties, you can discuss it in the WhatsApp group. And regarding the WhatsApp group, we will create a group and we will send you the joining link by email. So please, when you get tomorrow's class, we will again send you the link tomorrow morning. So at that time, in that email, you will also have the WhatsApp group link. So please join in the WhatsApp group. Okay. So that's it. Thank you so much. So we'll meet you all tomorrow, 7:30 p.m.
Okay.
Thank you, sir. Thank you, sir.
Thank you, everyone.
Thank you. Good night. Good night, sir.